Hello and welcome back to modelling surface reflections onto the real plane. My cough has cleared up, you'd be pleased to know. There were a few things that I didn't go into much detail on in the last part, but this will be the second and final part to modelling reflections. Now, in terms of the blinds to the left of me, which I briefly mentioned in the last part, there are also objects which are reflected onto the plane that are very difficult to see from external views. So we can draw them in many ways onto the real plane. We can, as I mentioned in the last part, that actually they can be drawn using basic shapes such as rectangles and also rectangles overlapping within wider and taller rectangles. But we'll leave it there. And we also used vectors to describe, I guess, from first person views, the x and y components of of light shining objects onto surface planes, flat surface planes. Now we also have shadows that that shine onto objects, and I won't draw on the below the board. But again, like I said, you can draw more rectangles, but we'll leave it there, and that's because essentially there are many more objects within the environment which can project onto and be mapped onto a flat plane, flat surface planes, right? But we can get into the equations as well and discuss them in a little bit more detail. Now again, we can see the energy being projected onto the flat plane, and we can use our understanding from circle geometry and polar coordinates to describe the equations representing this energy being mapped onto a flat plane, and then I'll describe the equations post drawing the semicircle. Now, when I refer to a semicircle, I'm not saying the semicircle which you're more than familiar with, but in this in this way, it's a partial circle. So we now have the the circle, and I should rub this out so you can see a bit more clearer. You can see how we move from a standard square, and the arrow is now representing its enlargement. And what I won't do for the purposes of this class is actually, when I say class, introduction, um, of the factors which cause the enlargement But what we do know is that a square so is enlarged onto this wider unstructured circle, and I think using unstructured language to describe this enlargement is more appropriate in this instance. Now, what we do know from basic circles is that the equation of a circle in the real plane can be represented by the standard equations which we are all familiar with. But what we'll do is we'll use polar coordinates to describe the equation of this circle using the standard cos theta identity for x and y, or cos theta or sine theta, where r is the radius of the circle. And so the equation can be represented by r squared equals sine squared theta plus cos squared theta equals a squared, where r equals a. And also I should mention that this is over the real plane r in, so this is now real, so I don't know if you can see that, but r in r3 over the imaginary plane. Which we use z here. What did I mean by blind spots? Blind spots are essentially those reflections which can't be seen from the reflection, but exist outside of R2. So when I refer to the real plane, in this instance, on flat surfaces, the R plane exists in R2, which is a flat plane. But blind spots and more applicable in this in language terms can be referred to as more closely aligned, I should say, with folds. So we essentially are describing them using a series of rectangles. These rectangles are all equispaced, so the distance between each fold on the real plane, and will, for all intensive purposes, for the purposes of this, we'll just describe using basic terminology x going all the way across. So then the total distance will be n times x. So the total length going that way across with height h, and so to get the total area, it's simply just n times x times h. And hopefully that makes a little bit more sense. So the area is nxh. And we'll leave it there. And that's essentially because we can add more complexity into it, which goes beyond the scope of this lesson. In the first part, we also discussed energy reflections and how we can use simple vectors in x and y to describe first person views of those reflections. So this was the length scales essentially, and these are all unit length scales from R3 into R2, or onto in this case. And we'll leave it there now. So we'll also discuss the equations for which we can use to describe energy in R3. So we'll have total energy from heat or light, for example, being mapped from R3 into R2. So we start from a basic square an enlargement occurring as such. And so the scale increases or the factors which cause the enlargement differ as the enlargement occurs not according to our basic understanding of series expansion. So to describe this in terms of our standard understanding of summation, we must apply more applicable phrases to describe this expansion. And so we can use calculus as well as our understanding from Algebra 101. We have also polar coordinates to describe circles, right? And we can use the identity x equals r cos theta and y equals r sine theta, where we find that r squared sine squared theta plus cos squared theta equals a squared R3 is an element of R infinity over the imaginary plane. And so now, using this logic, we have to actually keep it within this space, because essentially, and I missed a component, missed a part, but this is z for the imaginary numbers, because we're not referring to Cartesian coordinates in this case. And so we also know that r equals a, where r is the radius of the unstructured system. And I believe I've covered all grounds that I wanted to cover. And in the new year, again, as I mentioned in the previous video, I will be providing the solutions to the Navier-Stokes equations. And what hasn't been done before, and what I can say is that I will be providing those solutions, and so I have a 19-point proof as well as a separation of variables exercise one can adopt to solve the Navier-Stokes equations, and that will be done hopefully in due course. So I've just cleaned the screen once more, and I'll go into a little bit more detail on the asymmetric shape from the energy emission, and describe its evolution over time. So we'll start off, instead of a basic square, we'll start off with a standard unit circle, and how this then evolves onto becoming more asymmetric and unstructured. So over time, so following the enlargement, there is a factor causing that enlargement, which in simple terms will be very complex. So the unit circle will have radius r equals 1, and for these more unstructured, for the more asymmetric, I should say, shapes which evolve, the radius of the asymmetric shapes will vary along the angle theta, but also the change of the radius will be affected by time. So as time moves forward, the radius will change. So there's multiple components to this, which adds that layer of complexity. So actually, the radius of the asymmetric shapes is dependent on both the angle theta and time t. that equals the average radius, again dependent on time, and some function f of the angle theta of an angle theta and time, where f of theta t is an element of the complex numbers. And we'll add curly brackets for completeness. The y of its evolution is beyond the scope of the mathematical descriptions. But in terms of completeness, we've covered the angle and the evolutionary component of time, as well as both the so R naught actually is also, so R naught of t, the average, is a real number, and therefore we'll there that covers all bases. And so we have now a complete mathematical description for energy emissions from, and this is from, it's from R3, but it's in R2. So yeah, I have covered all levels in R2, and I guess the thing to remember is when projecting onto R2 from R3, one must maintain consistency within R2 in order to complete the mathematical descriptions in its entirety. So you cover time, angles, angular geometry, and completeness. And I would like to again thank you all for listening, and I look forward to seeing you all in the new year.
حي على الصلاة. في ربوع المجد كنا نرفع النصر المبين ونعيد الحق إن عبد رب العالمين. في ربوع المجد كنا نرفع النصر المبين ونعيد الحق إن عبد رب العالمين. كلنا عون الإله يا إله العالمين، كلنا عون الإله يا إله العالمين. مغيب الشمس يا أمي بجانب تلنا الأخضر، أنا وعدت أصحابي هناك الموعد الأكرم. مغيب الشمس يا أمي بجانب تلنا الأخضر، أنا وعدت أصحابي هناك الموعد الأكرم. إذا جاء النداء قيل حي على الفلاح، نداء الحق لبيت ولربي أصغيت. تركت الجاهلية، تركت الجاهلية، تركت الجاهلية، تركت الجاهلية. برفوع المجد كنا نرفع النصر المبين ونعيد الحق إن عبد رب العالمين. في ربوع المجد كنا نرفع النصر المبين ونعيد الحق إن عبد رب العالمين. كلنا عون الإله يا إله العالمين، كلنا عون الإله يا إله العالمين.
You ever seen unity like this before? Thousands praying faces on the floor, different nations praising the one Lord. Most beautiful thing that I ever saw. Marble, carpet or dirt, either way we're putting in this work. Thank Ish for the alert, cause I wasn't aware Islam was revealed to mankind those years, and neither was my peers. We was into Scarface and Wu-Tang, didn't know about Uthman ibn Irfan, I didn't know about Bilal ibn Rabah. Too busy acting hard as a rapper. Now when I'm wrapped up in this white cloth, pray I'm the total opposite and my heart's soft. Head down, stepping out the Grand Mosque, actions turned on, desires switched off. Now I see these little sisters with their lip gloss, looking Kardashian, listening to hip hop. Then I remember the sisters that ripped the cloth, wrapped up their hair as soon as the command dropped. Trading camels and palm trees back then, now brothers trading that cocaine and heroin. Looking at the times that we're living in, stressed in a penthouse, look what they were living in. Brother, believe me, I ain't giving in. When the imam speaks, I'll be listening. It's like it's at me, he's directing. The young boy filled up with sin. The young boy filled up with sin. It's like it's at me, he's directing. The young boy filled up with sin.
اللهم إني أعوذ بك من جهد البلاء، اللهم إني أعوذ بك من درك الشقاء، اللهم إني أعوذ بك من شماتة الأعداء يا رب العالمين. مغيب الشمس يا أمي بجانب تلنا الأخضر، أنا وعدت أصحابي هناك الموعد الأكرم. مغيب الشمس يا أمي بجانب تلنا الأخضر، أنا وعدت أصحابي هناك الموعد الأكرم. إذا جاء النداء قيل حي على الفلاح، نداء الحق لبيت ولربي أصغيت. تركت الجاهلية، تركت الجاهلية، تركت الجاهلية، تركت الجاهلية. برفوع المجد كنا نرفع النصر المبين، ونعيد الحق إن عبد رب العالمين. في ربوع المجد كنا نرفع النصر المبين، ونعيد الحق إن عبد رب العالمين. كلنا عون الإله يا إله العالمين، كلنا عون الإله يا إله العالمين.